Okay, this lesson is the first in two parts, or the first of two parts, on finding the derivative and looking at it as an actual function. Now, this should look familiar, very, very familiar, because you've been given something like this in two sections already. So remember the definition of a derivative of a function at some x value a. And you can look at that formula if you want to. Now compare that to this formula. This formula is for the derivative of any function, and this is the definition. So you see now f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So what's the difference between this and the one that you're probably looking at now with a is just the x here and here, or the a in your formula is replaced with an x, right? And that's it. That's the only difference. Similarly, we did look at velocities, right? The velocity is the slope of any position function, because this would be something like feet, this would be something like seconds. So rise over run would give you feet over seconds. So you know now that this gives you a velocity at any certain time t. Again, s is usually used for the position function. So this also is a familiar equation. All right, what's going to be different or new in this section, and we're just adding a little thing onto what you already know, is we're going to look at actually graphing the derivative. Because this says f prime of x, not f prime of a number, or f prime of a, where a is definitely going to be a number, this is just going to possibly come out to be something in terms of x, actually usually something that's still going to have an x in it. So it's going to contain the variable, which means it's going to be a function. If it's a function, you can graph it. So realize also that all the values, all the answers, I'm saying all the y values of f prime of x, but what I should be saying is all the answers to f prime of x. Those are the slopes of tangent lines to f of x at all the x values in its domain. So let's say you're given a function f of x. If you're given a function f of x and we get f prime of 2, that's the slope of the tangent line to the graph at 2. If I get f prime of negative pi, okay, then I'm getting the slope of the tangent line to this graph at negative pi. And again, all we have to do is, make sure that those x values are in the domain of the function. If they are, then there's going to be a slope of a tangent line there. Maybe sometimes it doesn't exist, but we'll get into those cases. Okay, so we can use a graph of f then to sketch a general graph of f prime, and let's figure out how. Okay, so let's think ahead to if we're going to graph f prime of x. F prime of x depends on the tangent lines, right? The tangent lines of f of x. So again, this does not say prime. That's not f prime of x. That's f of x's. I probably should have worded this differently, like where is the tangent line of f of x horizontal? Where is the tangent line of f of x positive? And so on. But anyway, where these things occur, where we're looking at horizontal lines, positive lines, or negative lines for little tangent lines, that's going to help us to graph it. So let's think about what is the slope of a horizontal line. The slope of a horizontal line is 0. Well, that's all a derivative is, right? It's the slope of a line. So if we were going to graph it, we're just going to plot some, any place that the tangent line of f of x is horizontal, we're going to put basically an x-intercept on our graph of f prime of x. Okay, now where the tangent line slopes are positive on f, then we're going to want to plot positive values on the graph. So where are positive y values? They're above the x-axis. And similarly, where the tangent line is negative, our derivative is going to be below the x-axis. Okay, so for this example, you want to use your calculator to graph f of x, and then we are not going to use the calculator or anything at first to sketch f prime of x. We're just going to use the things that we looked at the last page, which is where the derivative is 0, where it's positive, and where it's negative. Then after that, using the limit definition of a derivative, we're going to actually find f prime of x, and it's going to be in terms of x, so it's going to be a function we could graph, and then we're going to compare those. Alright, so where is, okay, so here's f, right? And where, oh, I was going to say, why couldn't you see that? I circled it in white. So here's f. This is the function f. Now I want to see where is the slope of its derivative, or the slope of its tangent line going to be 0. And that's right here, and that's right here, right? So where its slope is 0, if I'm graphing the slope, I graph on 0. So hopefully I can graph this at the right thing, because it's with, no, not even close. It's with my finger instead of with the pen, so it's hard. Also, let's try it over here. Alright, so that's supposed to be on 0. Alright, now, where the slopes of the tangent lines are positive are here. These are all positive slopes. And then over here, they're all positive slopes. So where there are positive slopes, I want the function to be above the x-axis. Where there are negative slopes, I want the slopes to be below the x-axis. Now you see I randomly just sort of went up, but see how these are really high numbers, or really high slopes, so these are really high numbers. These are really high slopes, so these are high numbers. These were relatively lower slopes, so they're lower numbers. And here it looks like about as steep as this gets is maybe like a negative, not even 1, negative like a half or something. So let's not swing down too far, but these are all negative numbers down here. So that's my graph. That's what I'm saying is my graph of f prime. Okay, so in the next video we're going to find f prime of x by using the limit is delta x, oh wait, that's from the other book. You guys use h's. The limit as h approaches 0 of f of x plus h minus f of x all over h. If you want to, you should probably start that because you have the function right here. And remember, Pascal's triangle comes in handy to cube a quantity. Alright, so I will pick it up here in the next video. You can try this if you want before you play the next video.